This is the second session of our international seminar made with colleagues from Tübingen University and from Université de Lorraine in Nancy. So we are all obsessed by algorithms. We are all obsessed by politics and ethics behind computers. We would like the things to be as public, clear, transparent as possible. So these talks aim at exploring the possibilities of making this universe transparent and good, so to speak. So today I'm very happy to welcome Professor Carmela Troncoso, and she's going to be introduced by one of us, namely Maël Pégny, who was working at the University of Lorraine 2 years ago and is now in Germany. Maël, the floor is yours.
Thank you, Anna, for the general introduction. So let me say a couple words about Carmela Troncoso. Carmela Troncoso has several interesting properties. The first and most interesting is that she is the person it took me the longest in my life to actually get in my seminar. So it's been 2 years since I've been chasing down Carmela Troncoso mercilessly through bad luck and COVID pandemic. And I finally had a chance to put my hands on her. So I'm very happy for this to happen today. Carmela Troncoso is also a professor at the École polytechnique fédérale de Lausanne in Switzerland. And she's mostly specialized in cybersecurity. If you have one of those cool apps that can detect your health status without sharing it with a central database, well, it's probably running her code behind it because she's behind the DP3T system on this. So that's a main hat. But she has also a second hat, which is an interest in fairness that that was a basic reason for our exchange a couple of years ago. And that's what she's going to talk about today. So without any further ado, I'll leave you the floor, Carmela.
Thank you, Maël. I didn't know one of my most interesting properties was hard to get. This only happened in COVID, to be fair. Indeed, my life was sequestered by these contact tracing apps for 2 years, and I had to ask Maël to give me a rain check a number of times, but I'm very happy of being here today. And what I want to talk today is a little bit about how some of the current trends in machine learning, kind of fairness being one of them, actually have this mismatching conception of what are our concerns, and then they really cannot address any social problem that they create because their models are just kind of off. And while doing this, as Maël said, I come from the cybersecurity and privacy world. I'll talk a little bit about how, when we think about machine learning from an adversarial perspective, things to change. And the context of this is this machine learning revolution that we live in, right? In which machine learning is just getting everywhere in our lives. Like nowadays, it's so hard to escape. Kind of latest crazy thing I saw is a toilet that will use machine learning to know if it is you who is sitting there. I have no idea what good that can make later on, but they can recognize your ass apparently. And in this wonderful world, what happened is that machine learning also became a tsunami. It became a tsunami for privacy reasons and for social justice, right? And what I understand, you're a little bit more understanding on the right, but actually privacy is essential for our democracy. It's essential for us to be free and for us to have our own personalities. So if we destroy privacy, there is no space for social justice because there is actually no space for individuals. There is no space for us as humans. So on the privacy side, suddenly machine learning became this thing that allows us to learn anything about anybody, from any action, from how they click on the phone, from how they look at the camera, from how they breathe. Like everything can be learned from people. And on the social justice side, machine learning has, become this thing that now makes decisions for us. For any kind of thing that we have to make, now there's going to be an algorithm somewhere that is going to have an influence in the decision. And we, in the last 5-10 years, we have seen a lot of cases in which this use of algorithms actually has proven to be very wrong. But no worries, because, computer scientists, the ones that created this thing, they said they will also rescue us. And for that, they are going to come up with these excellent new algorithms like privacy preserving methods and fairness methods, and none of these problems are going to happen. No worries, guys. We're going to have algorithms, but we're going to be fine. And today I'm going to talk about a bunch of hurdles that happened in the path of these rescuers, in the terms of pitfalls of how people think about privacy, especially coming from the machine learning domain, and also how they think about fairness and kind of the limits that the fairness frameworks that we have nowadays have. So let me start by a privacy evaluation on something that we call membership attacks. And a membership attack means that whenever we have data, right, and we will have a model that we learn from the data and then allows us to answer things about the data, like a parrot. And membership attacks enable us to actually, just by querying the model, by interacting with the parrot, to learn things about the data, in particular whether samples were part of the training data or not. And the concerns that these membership attacks kind of tackle are first a real privacy concern, that the fact that you're part of a database may actually reveal a condition. So imagine that we go back to this case of Compass, one of the most used data sets for this kind of social kind of issues, where the task is to predict recidivism, whether a criminal will actually commit a crime again. The fact that you belong to that database on itself, regardless of whether you're going to repeat your crime or not, means that you were actually a criminal at some point. So it may be actually kind of very problematic if people can learn this just from these models that we're going to use. And also the other problem, especially from a legal perspective, and if we go for the general data protection regulation, is that membership may mean that you can actually link person to data. And once we have that, that means that maybe the database becomes personal data. And that kind of can have, you know, a huge impact on how you can use this data. So these attacks are pretty important. And how this attack works is that this magnifier here is implemented as another model. So as an adversary, you take your own data and then you train a model. And what your adversarial model allows you to do is to ask the model, can you classify or predict something on the sample, whether I want to know whether it is in the model or not. And then the model will give me an answer, and general model not only gives you an answer like we typically think about a classification, but models actually output more data. They output confidence vectors, they output losses, they output more information that typically the people that actually query the models use as part of their usage of the data. In the case of our adversary, the adversary is going to use this extra information to try to know whether X is or not in the original data. And these attacks are pretty effective, depending on the data, more or less. And so the question is, once this is started, now we want to know, okay, if we're going to publish a model, we want to know if it is vulnerable to this membership or not, because we want to know whether, well, first, what we're handling is personal data from a legal perspective, but you also may be caring actually about privacy, and then know, well, can people learn whether a particular X is in the data or not? So this vulnerability is typically measured as the probability of success of the adversary, the probability of success when you say X is in the data or X is not in the data. And the thing is that typically in kind of the literature, you always measure this as the average over the population. So you take all of the possible X's that you could think about, and then you try this attack, and whether you succeed or not, and then you give an average metric over this. And in our work, we build on others people's work before to show that actually vulnerability is like we have seen many times in the fairness literature, is also disparate. There is a disparate privacy impact of these attacks. It turns out that you could have some outliers that have a high privacy risk, and maybe they are disconnected, but they are still highly recognizable as a membership inference. But it also can happen that you have a particular socially salient group that has also high privacy risks. So in this case, we have outliers that are kind of disconnected, but all of them have high vulnerability. In this case, we have maybe outliers that are actually very connected, and they become to a social group. And now this has huge implications, because if we think about the concerns, right, like for these guys here in the left, even though the average may be okay, like the average population here is happy, they don't really have maybe a big attack, right? Maybe the success of the adversary is around 50%. So that's more or less the same that if you were not doing the attacks, kind of your prior information. But for some of those, you would actually have the condition revealed. So it may be that some of these criminals in the compass data set actually are very recognizable from the output of the model. And then they really have a privacy problem. And even more relevant is when we have subgroups that are vulnerable. Because then again, if we think that maybe all of the members of a subgroup, and just not one outlier, but like systematically, we have members of a group that can be linked to this data so they can be re-identified, this becomes personal data. And that means that when we take the typical attacks or typical results on machine learning or computer science paper, where we care about the average and not really look at what happens on the tails of the distributions, we're having the risk of having a huge privacy washing, because we're running the risk that we actually believe that the algorithm, that the model is kind of privacy preserving, that we cannot extract this information from the model. But even though on average you cannot, there is a subgroup that you can. And that becomes extremely important, as I said before, especially when we're talking from a legal perspective, we're deciding, because one thing can maybe to discriminate or having one outlier, right, that has a privacy problem. I'm not saying this is good. I'm saying that from a law perspective, the law may decide that this is actually something that may be okay. We can still consider privacy preserving, but when we have a systematic discrimination, because systematically a group is more vulnerable, then this thing changes. So this, so we started this, and then we also started like, can we solve this thing? And then the first question that one may come to mind is like, okay, I mean, we have a ton of fairness techniques. Why don't we apply one of those? If I believe Maël in the first seminar here explained a lot of these definitions and how they could be used. And what we find out is that if you want to use a fairness technique, you can only solve the problem insofar as the adversary kind of cares about the same subgroups as you do. So you need to remember that the fairness technique, what it says is we're going to try to make equal the output for different subgroups. And you need to make sure that the subgroups you choose are the subgroups of interest for the adversary. And also that what equal means, so what property of these subgroups becomes equal out the output is also the same. Otherwise, fairness is not going to help you. Fairness will make that particular definition happen, but does not give you any warranty that an adversary interested in something else cannot actually deploy the attack. So fairness techniques are not going to be very useful. And the other main technique that we have on our computer science backpack for solving these things is differential privacy, which is a technique that puts noise in a particular way on the way we do computations, such that the output of this computation doesn't reveal anything about particular individual points in the computation. So it turns out that differential privacy does help and does address the problem. It can bound this disparate vulnerability. Now, this noise that I said comes at a huge cost in performance. And what is even more relevant, I think, from the kind of social issues that we're worried about here in this group and in this talk, is that differential privacy is also known to have disparate impact. So it can provide privacy, but also this cost in performance is going to be non-uniformly distributed. And it turns out that the cost is larger for minorities. And why is this the case? Is because if you think about And this one here, right, the minorities, kind of the corners of here or the corners of this outlier, they're very different than the rest. So to hide those, you have to add more noise to them. And that means that essentially you are kind of removing any utility for those particular outliers. So sure, we can get privacy, but at a huge cost. That means that maybe we're erasing minorities. And also we have to make, to think about what that means. So if you want to know more about this disparate vulnerability, here is the paper in which we describe our study. And what we describe is that, well, when disparate vulnerability exists, and it will exist whenever the distribution of any model output property, like what did I say, said this before, the loss, the confidence, or any property that we may concoct is different from samples that are in the training data set and outside of the training data set. And it turns out that systematically minorities, so subgroups that don't have many samples in, have a much bigger disparate vulnerability than the others. Yeah, we have this effect of the poor get poorer kind of thing. What makes this problem even more problematic is that estimating this disparity is non-trivial, because sometimes, especially if you have very little points in your in, so when your group of interest, the group you're trying to protect or to know whether they are being discriminated is very small, it is very hard to prove statistically, right, to have significant results that actually allow you to say with high determinism that this group is being discriminated in terms of privacy. So that means that the concern that we have is somebody more affected than others, and how much affected they are is very hard to address, because for the cases that we're the most interested on, it is the hardest to have this disparity. And then, as I said before, we also have a discussion of the legal implications when this happens in socially relevant subgroups. Any questions so far? As I said before, I'm happy to take questions during the talk if you guys have. Otherwise,
yeah, all good. Thank you. As for now, yes.
Yep. Otherwise, we can talk about another method that has come lately into play to actually kind of bring this kind of no worries, we're going to have privacy in all of this machine learning revolution, so all of your fears are unfounded. And this is synthetic data. And synthetic data comes into play because in order to do machine learning, people need data. This is a given, right? And then we know that if you just give people the data, the raw data, this is a big privacy violation. So people want to have a good privacy utility trade-off. They would like to have data that they can use to train their models and to do operations on while having high privacy, right? This will be the ideal case, this holy grail that everybody wants and we're looking for years, even before machine learning was a boom. Like everybody wants to have data to have such a thing. But it turns out that traditional techniques to take a data set and sanitize it and remove all of the private information from them, like anonymity or closeness or diversity, are actually not very good at this. If you want to have good utility, then it means that you're going to have low privacy. You could also move to this corner here and have very high privacy, but then you're going to have very low utility. So that's the world in which we lived, right? And there was a lot of work on anonymization, and again, techniques come up and research show that they are completely flawed. And we're always in this point here. And therefore, from a machine learning perspective, this is a disaster, right? Because you cannot take data and just strip it of personal information, say this is not personal data, and stick it in your pipeline to use. But enter synthetic data. And synthetic data is the new holy grail, is the thing that's going to solve everything. And the idea of synthetic data is that we're going to take this raw data set that we cannot disclose because it's full of personal data, and we're going to create what we call a generative model with it. A generative model is a mathematical construct that is going to extract the characteristics of the data, particular statistics of interest, and then we're going to use that model to generate a new synthetic data set. And this synthetic data set, what the promise of synthetic data says, is that when you give it to the analyst, it allows to have the perfect statistical insights that they want. But when you give it to a privacy adversary, there is no way they can recover any information about the raw data. And this is kind of course, like who wouldn't want this thing, because that enables us to unleash the potential of data. That's great. And then ideally kind of synthetic data would be here. But what we find is that synthetic data really didn't have any good evaluation in the literature or in industry that actually proves or shows that is actually in this quadrant here. So me and my group, we set to do an evaluation. And the first thing that we have to say is that what really matters for synthetic data is not how much privacy it gives, is does it give you more privacy than publishing the real data, right? We're really caring about the relative thing. What I mean here is that if the real data already didn't carry a lot of private information, then you don't need to transform it. You don't need to do anything with it. You can just publish it directly. So the question that we're having is, does publishing synthetic data reduce the privacy loss with respect to the real data? And ideally, if synthetic data is this holy grail they promise, we would have a super high privacy gain. And if not, it will be similar to traditional anonymization techniques, we would have a very low privacy gain. And when we think about the concerns, so what kind of concerns are people trying to address here? Normally we say that they're trying to address the concerns that you try to address in anonymization. And we took for our work the definitions from the Article 29 Working Party in Europe that said that, you know, kind of characteristics of this anonymous data, they cannot link it to a person, like the typical question, like is the governor in the data set? Is somebody in the data set, what we had before, membership inference attack? And also to be anonymous, it should not allow you to make any inference about a particular user. So you shouldn't be able to learn the governor is in the data set. And if you learn it, you shouldn't be able to learn what attributes does the governor have in the data set. Okay. So we went and studied a bunch of synthetic data algorithms because in the literature, we never found, like when you look at these proposals, right? There is really no proof that actually this gives any privacy gain. On the one hand, you have the people with blind faith saying like, well, this is kind of artificial data. There is no link to the real data at all. And there are the others that are a little bit more trying to do something. And then they just look at the distance between the synthetic data set and the real data set with some mathematical distance. That means absolutely nothing. And then if it is far enough, for some definition of enough that also doesn't respond to any concern, then they say the synthetic data is good. But none of this allows actually to say whether these concerns are addressed. So we went and worked on this, and here for the shortness of the talk, I'm just talking about linkability. We went and looked at, does synthetic data really give a privacy gain? So here we have the privacy gain. We say low means this is the same as having the raw data, and 1 would mean this actually gives very good protection. And what we see is that traditional sanitization, as we knew before, for some points, these points here are kind of outliers, the ones that are hard to protect. For some points, give us very little gain. For some points, it works very well, but you have no warranty that you're not going to have points that are very vulnerable. Then we look at synthetic data algorithms that are not thought for with privacy in mind, and we see that they have some improvement, but not really. Right? We still have outliers that don't have very big privacy gain, and in particular, that don't have much more privacy gain than traditional sanitization. So we don't need to invent new methods. We already had something that was not very good trade-off, but you know it's already there. You don't need to reinvent the wheel. And then when we put privacy in this, as I say, when we put, again, differential privacy, this idea of we put noise, indeed we see that epsilon is a typical parameter to say how much privacy you're putting, how much noise. The smaller the epsilon, the more noise. So the more noise we add, we see how the privacy gain goes up. So this is great because we say, okay, if you tune the epsilon kind of small enough, it seems that you're really protecting these people. But again, what we care about is not the privacy only, is the privacy utility trade-off. So we went and look what happens then. So if we now have the super privacy preserving models, do we actually get this thing that allows us to train freely as we're promised? And what we see is that when we look at prediction task, right? Here we're looking at the accuracy of a machine learning model. If we're training on the raw data without anything, we have above 0.7 accuracy. And we see that if we sanitize, we didn't have much privacy, but we have a quite good utility. There is almost no loss. If we move a little bit more into the synthetic data scenario, where we didn't have much privacy, we also don't get a big loss, a bit more, but it's not bad. Now, the moment we start to put noise and we move to the part of the graph where we want to be in terms of privacy, we see that we go to the part where we don't want to be in terms of utility. Utility goes down, sometimes going even below kind of a random guess. I hear somebody open the mic. Is this because there is a question?
No, I don't think so.
Okay.
This is someone who just entered.
No problem. Yeah, so then we see again is that we have here a bit of a problem. We also looked at other utilities that people want to do with data, like computing statistics, and we have the same problem. Sanitization, or kind of the very non-privacy preserving synthetic data, gives you good utility, but the moment that you put noise, you can go up to 6 orders of magnitude in the error that you have. So that means that synthetic data doesn't really come as this trade-off that we were told. And we also look at the last promise of synthetic data, which is we're going to have, you're going to be able to do good outlier analysis, which is something that previous anonymization doesn't let you do, because you kind of kill the outliers in order to make the data privacy preserving. This is very important for fraud detection, for anomaly detection, in medical investigations, where you want to find kind of rare cases that actually allow you to show there is a new disease. So we want to know whether the anomalies that you would find in the raw data set, you also find in the synthetic data. So we made an experiment in which we measured the influence of how one outlier helps to predict other outliers. And it doesn't really matter kind of the exact meaning of the graph, but the magnitude tells you for each outlier that we have here, outlier 1, 2, 3, 4, and 5, how much influence they have on the prediction of the other outliers. They can make them a worse prediction, reducing the accuracy, or they can make them a better prediction, but they do influence each other, right? They're important when you try to influence. And what we see in this series of graphs is that as we move to synthetic data with noise, we see how this influence that we had, that is kind of strong, right, disappears. So essentially what the synthetic data is doing is not telling us, but deleting these outliers. It is removing their influence. So all of the things that were good about synthetic data actually maybe are not so much, because all of the promises that they give actually are not fulfilled when you really look into it. So if you want to learn more about this, now this would be the paper. And kind of the main takeaway is that synthetic data is not particularly a better trade-off than traditional sanitization, and that the protection is really non-uniformly distributed. So again, we have the problem that it will not protect the same different outliers. And even more worrisome, because synthetic data is based on a machine learning technique where you learn a model, and you already may know that nowadays we don't understand very well how models learn, and we're far from this interpretability and explainability. There's another holy grail. So who will receive protection is actually unpredictable. And we have kind of a much bigger problems than with traditional sanitization, where, you know, we may get a not so good utility privacy trade-off, but we know what we're getting. We know who exactly we're eliminating. We know how we're modifying. So maybe not be good, but actually we know what we're doing. But when we put synthetic data, it is a mystery what is going to happen. And it's really something unpredictable. What are the effects that you're going to have? Excuse me, there are a bunch of papers. Yes?
Sorry, Carmela, this is Karen for. I have a question, if I may. I just wanted you to tell me what you mean by syntactic data. This is maybe something I missed in your talk, but I was wondering, you're talking about noise, adding noise, but we can create synthetic data that's not noise.
What I mean by synthetic data, yeah, it's here. So we have the raw data, the real data. We're going to train a model, a generative model that is going to learn characteristics from this data. It's going to need particular statistics. You're going to learn about correlations between different variables in the data. And then we're going to use this generative model to sample what we call a synthetic data set. And the synthetic data set is supposed to have the same characteristics that the generative model has collected, which come from the raw data set. So far, so good?
Yeah, I do it. I mean, this is what we do. But my point is we are not generating noise.
When we put noise is that it is known that if you just do this process like that, you have not put any kind of privacy protection like on purpose on it. And then it is not so surprising, the results that we have, that you don't have very good privacy, right? But then come the algorithms that add differential privacy. And what they do is that when they do this learning step here, they do add some noise in the steps. And the noise is very controlled, and it's made in a way that you ideally make sure that you're still kind of preserving the statistics of interest. And then you produce the synthetic data set. And the people that propose those kind of differentially private synthetic algorithms, they say we have high utility and high privacy. And what we show in our work is that this is actually not true. That when you really evaluate the privacy, you can be in one of two options. Either you do have high privacy, but you also have low utility, or you have high utility, but that means that you have low privacy. Did this help clarify?
Yes, I think I would need more details, but I'll have a look at your paper. Thank you very much.
Yes, I'm sorry. I didn't want to go too deep into the details, but if not, at the end, we can go a bit more. I can find more explanation for this. Yep, and one of these reasons while this thing happens, what I said, like you can be on a high privacy, a low utility, that is kind of intuitive, because if you put noise in the inputs, right, you're going to have noise at the output and the utility is going to go low. But what happens in many of these differential privacy implementations, that they have bugs. We found that so far, every kind of implementation that it was famous and used out there that we analyzed, they had problems in how they were using this differential private noise. So the theoretical warranties that should come from the use of this very particular noise really didn't hold. And that means that the results on utility of this high privacy, high utility do not hold. And is where we are again back in this trade-off similar to sanitization. Cool. Okay, so that kind of is a problem, and it's a systematic issue in machine learning privacy evaluation. One of the problems is that because the machine learning field in general focuses on averages, right? And that's how we get to the problem of disparate impact on the output. Evaluations do the same. They kind of tend to always go for the average case, average user, and tend to underestimate the privacy threat for outliers. And when you look at the outliers, it turns out that the protection is always lower. Also, the typical adversarial models that they use do not reflect the worst case. They do not reflect an adversary that is really trying to go and actually extract information, like this idea that a distance between the synthetic and the real data is actually any proxy for how good the adversary can make an inference about whether a point is in the data set or not. And then we also kind of see that machine learning in general takes kind of the wrong reference frame, right? This idea of how much privacy synthetic data gives, instead of looking at how much more privacy than the raw data it gives me. or what is the privacy for the average population instead of the worst case privacy. And that means that the main privacy concerns that we have are not addressed so far in the literature, or we have even further harms because we're considering kind of things that are that they're not going well, or we go for these averages and then we use things like differential privacy, which respects our average utility, but then kind of makes big damage for outliers. Cyrille, it's a very good question. What is a bug in this context? So for differential privacy to work well, the noise that you put into your system has to be independent of any input. Now, when we do synthetic data, in order to get high utility, what you need to decide my synthetic data in which ranges it is going to fall. I'd imagine we're doing synthetic data, like a lot of the things we looked were medical data sets in which you have, for instance, one column that is age. And to get the best utility, you would like to have a distribution of age that is as similar as possible as the original data set. So what people do in their implementations is they learn the ranges of the output based on the input data. So they don't have the input data, but they have the ranges. And it turns out that those ranges carry enough information about the input data to reveal information about the outliers. And this is a bug that we see again and again and again. And when you solve the bug, meaning that instead of learning the ranges from the original data, you kind of learn them from public data or from common sense, like for ages, right? We could just make my range is between 0 and 100, and I'm going to divide this in buckets of 10. Would be something that we could imagine that works well. And then is when you get the big hit in utility, because now your synthetic data kind of works in a different dimension than your real data. Did this help, Cyrille?
Okay, it was pretty technical for me, but okay, fine. Thanks a lot. Please go on.
But kind of the main idea of what is the bug is that they learn information from the original data and they inadvertently feed it to the computation of the synthetic data. So the synthetic data secretly kind of carries this information and the adversary is able to extract it. And that kind of breaks one of the assumptions on which differential privacy is supposed to work. The idea that the output doesn't have kind of influence from the input.
Okay, thanks.
And for Maël, to remove the bug, you can remove the bug, right? And in our work, we do those things by removing this influence from the input to the output. And as I said, you remove the bug, but what you get then is actually the impact in utility, right? Because we don't say you cannot have bugs. What we say is that the idea that you would have your utility privacy in this top right quadrant, the ideal case, is not true. You need to, there is indeed a privacy utility trade-off. With the bug, high utility, low privacy. Without the bug, high privacy, low utility. Cool, thank you for the questions, guys. So with this, I wanted to enter on my third kind of pitfall of how I see machine learning, the machine learning field, thinking about social problems or issues that kind of really do not work when you look at them from a security lens on this inside the style perspective. And one of those is the fairness frameworks, right? So we have this problem with fairness, and there's a lot of issues with this, even more than with privacy, because when people realize the difference of groups will be treated differently, this is very bad. So no worries, because we're going to have a lot of A governance and a lot of A ethics guidelines that are going to help us to do this thing. And I'm very thankful for people thinking about this and putting kind of these problems, but these frameworks have a big problem, right? And in the ideal operation that we have, so nowadays we would have users that interact with an AI system, and what we see before this governance framework and solving these problems is that we have bad effects on this on the users, right? And these typically tend to be particular subpopulations. Well, they get denied more loans, or they have more problems to be recognized with their face. Latest things I've heard is that prevents people from accessing their bank accounts, prevents people from doing exams, because nowadays, apparently, if you do an exam, you need to have one of these proctoring software that needs to recognize you. It's out that darker skins have a harder problem to this, which means that they have a harder problem to do the exam, and so forth and so forth. And the idea now is that we're going to have these frameworks, governance frameworks, that are going to come here and they're going to solve the problem. And we're all having good effects, and the power of data is going to be ours. But the problem is that there are two hidden assumptions between these ideal operations. The first one is that the system goal is fine, right? Like this kind of systems do not really put into question the idea that the AI system may be doing something undesirable. It's just a question of, are people equally well affected, right? But now we had the question, of instance, of this proctoring software, and we could have a philosophical discussion for hours about how is this a good idea on itself, regardless of whether it works well for people with all kind of skin tones. These kind of frameworks do not address the problem of whether the system goal is good or not, and whether this is going to create other harms. And the second one is that if you see this arrow, the arrow kind of goes on the system. So this kind of frameworks assume that the owners of the machine learning will have the incentives to fix the problem, which we may argue, maybe also because maybe there's a lot of legal pressure for that, but that they also will have the means, the capability to actually understand where the problem comes from and actually be able to fix it. And I'm going to argue here that this is not always the case. And for this, I'm going to use as an example a very pervasive type of artificial intelligence system, which are optimization algorithms that we have nowadays everywhere. And when we optimize, the idea is we want maximum value, typically economic value, from manipulating people. And this is what happens when we have advertisements, right, that try to show us the best advertisement for us to click. We have this in credit scoring, which will give the loans to the people that have the most probability of returning them, so that the economics of the bank can actually grow. And we also have this in applications like, for instance, routing, which is something that we use nowadays a lot, right? Whenever you want to go from A to B, you look at in Google Maps, or you look at in Waze, and we'll give you a route. And this route kind of optimizes your time. And that's the same thing. It manipulates you, it manipulates a little bit what you're doing in order to give you the best. And when we think about an optimization system that inside has algorithms, right? The idea is that you have users, you interact with the optimization system, and you have them a benefit, optimal benefit. Life is cool. And this system turns out that it will also affect users, right? It will affect users because, like for instance, in the case of Waze, how different cars are going to move and are going to change routes, it turns out that affects people, right? Because it's changing the routes, but so far they're happy because they found a shorter route. But it turns out that optimization systems, the ones that we find in the wild, not only get interactions with people, they also take interactions with the environment. If we think about the advertisement system, advertisements don't work only on what you directly click, for instance, on Facebook. Facebook is collecting inputs from everywhere, right? From everywhere where they have pixels and they know what you search, they know which news you read. They take a lot of information from the environment. They also take information from the offsite world in terms of, for instance, people or these companies buy a lot of shopping lists and credit card statements, kind of things. In Europe, it's not so legal. In the US, you can buy a lot of stuff from people. Or if we look at the Waze application, kind of the map is very important and very relevant, right? Because it also gives information for the system, and if the road changes, the optimization system changes. And it turns out that then the optimization system not only changes people, it also changes the environment. As I said before, in Waze, it changes where people move. And in the online world, it also changes because it modifies, for instance, how we click, what we're shown, how we're shown. Yeah, we have a lot of conversation about this. What you're shown on your Twitter timeline completely changes. your online interaction. And the system is even more complicated because in all of this, there is also the market. There are market forces. You have the optimization systems try to improve. In the case of advertisement, this can be bids of advertisers. So you not only are shown an ad of Coca-Cola or Evian water because you drink more sodas or more kind of water kind of type of things. It also depends on how much these two companies are willing to pay for the advertising. So how you are affected and the environment is affected by the market, which on the other hand is also affected by the users, right? So this starts to be kind of much more complicated. And on top of everything, we also have the fact that not everybody uses the system, but still people are affected. That we can see in the case of advertising, how advertisements work and how the people that use them kind of click changes prices that may affect what non-users of this system actually have to pay for things. Or in the case of ways or these rerouting applications, even the people that don't have cars and have never owned a smartphone and don't know anything about this application may be affected because now it may happen that they live in the value of Paris. And now, instead of people using the ring, they are traversing their very quiet neighborhood. So these people that didn't know anything about the optimization system are now affected. So now the question is, how can all of these effects be accounted for the optimization system that doesn't have a say, many times a view, like in non-users, of these kind of problems? What are these harms? How can we help with externalities? And when we look back to the fairness and privacy research, we see that this is very limited. So fairness really kind of only checks bias within the system. Again, they don't care about what happens outside. As long as my outputs fulfill a definition for both subgroups, I'm happy. And in privacy, kind of, we're always really, sorry about that, so really mindful of the individual's data, but not really about the global and these global decisions. So we have nothing that takes about this incentive and means. And what happens if the machine learning owners don't have the means to know about these externalities of people that they are not using? All of this is decontextualized for the goal. Nor privacy nor fairness algorithms ask you, is your algorithm going to do good or is your algorithm going to do bad? And ignores many other harms that they have here, right, that may come from exploration, may come from environmental impact. None of this is actually taken into account. So, sorry about the change of the title. This would be more about fairness algorithms not being the holy grail. Is in our paper on protective optimization technologies, where we actually kind of formalize all of this, just to show that machine learning needs to really take into account the big system when addressing harms. Focusing on the algorithm is very narrow. And if on top of that, you only focus on the A provider, on the one that actually owns the model, your capabilities to change things are extremely small. And not only that, it also gives power to this model deployer to decide what is good, because we have no say in on this. And it cannot address many harms that go beyond the ones that you can actually model by only looking inside the algorithm. And if we actually have a more holistic view of this and actually have better protection and give more protection to the users, maybe we also need means for these users and also the non-users to enforce governance. The idea that governance is only going to come from the ones that actually are deploying the algorithm in a fair way from everyone is really, really crazy. And again, in this paper, we do propose ways of actually building technologies that from the outside allow us to influence those algorithms and maybe change and maybe regain some of that control and that power that has been taken away from us by means of everything being focused on the algorithm and those that deploy it. So to finish, my takeaway is that the machine learning research is many times, most times, actually limited in the way in which they think about adversaries, how adversaries may act and what may do. In the case of this fairness framework, they don't think about the box as an adversary. and therefore they completely trust this box to do things, but maybe the box cannot on itself. And it's also very limited in the definitions, how they capture concerns or how they model them. And as such, machine learning is very limited in the way they can address social concerns. And the way in which two of the main fields that kind of tackle this, which are fairness and privacy preserving machine learning, are tackling the problems, is so far extremely kind of narrow, and is going to be unsatisfactory in the long run if we really want to have the social concerns created by machine learning addressed. And this is all I had to say, and I'm looking forward to an engaging discussion.
Wonderful. Thank you so much for this very interesting, even though not entirely optimistic, I would say, but that's super interesting. Maël, I trust that you wanted to follow up with this, so I'll give you the floor.
Can you hear me, Carmela, everybody?
Yes.
Okay. So, all right. So maybe just we'll wait for people to show hands and maybe type question in the chat. I can launch the discussion with a little remark and a little question. So maybe my first remark would be that on your fairness part, in the way you describe the fact that the fairness literature in AI has been really focused on the algorithm itself and on the model, and from a governance point of view, on the model deployer, him or herself or themselves, and do not take into account more systemic effects on non-user externalities, effects going to scale, and so on and so forth. Now, I think we've seen you join a certain trends that I've seen time and again in the literature, but not so much, which is to see that this all focus in algorithmic fairness leads to a focus on decision time, so to say, and what happens when you take the decision, and forget what happens upstream, forget what happens downstream, and forget about systemic effects. So I think there's maybe an emerging trend there, but maybe still a bit weak in the literature. So that would be my remark on the state of the art. You have the right to tell me whether you agree or not. But my question was, so you said you had you wanted to address some of those concerns with protective measure would give back some powers to users or people outside of just model deployer. Can you give us more details on this? Because there's often, among technologists, this very optimistic message that our technology is going to give back power to the user, right? Mm-hmm. Which is a very common theme among people who want to criticize the state of the art in the technology. And often it quite doesn't happen that way for fundamental political and economic reasons. So could you give us more details on that, and could you give us more details about what kind of political challenges you anticipate on trying to implement those innovative solutions for transferring governance power? Thank you.
Thank you. So for the first project, we completely agree that now I have focused mostly on the decision part side. You gave me 45 minutes, kind of 1 hour-ish thing, so it's hard to go through the whole pipeline. But indeed, and I'm very thankful that some work actually start to look more into the upstream and what happens before, and how what happens before does have an impact, right, on this decision making. But indeed, I have not talked about this today, but this is essentially super important, including the process of collection, how you collect the data, where you collect the data, how you pre-process it before you even start doing all of these things. All of those have extreme influence on the final result. But to go back to the protection optimization technologies, you're totally right. And when you take a look at the paper, which is actually extremely technical in most of it, but no, we don't argue, and we don't want to argue that technology is going to be the solution. A lot of these technologies are going to have to be mixed actually with reality and with political powers to change. So one of the technologies that we talk about in one of the ones that we propose is indeed to solve this waste problem. And the idea of the problem of waste is that, as I said before, like little villages, especially in the banlieue of big cities, kind of are getting invaded by these cars at peak hours, and they are completely destroying their environment and the dynamics, right, where kids were playing in the street, where they had very silent roads and streets, and now they don't have any of that. And kind of what we propose there is that you can actually use technology. You can use the idea that Waze is going to optimize the routes, and they're going to optimize the routes, and they're going to send people there as long as it is kind of shorter than going through the highway in a peak when there's a traffic jam. But if you can modify the layout of your city a little bit, right, maybe modifying a little bit the lights in red and green, or maybe kind of making people do a little bit more of a serpent, you can increase the amount of time that it takes to traverse your city in a way that traversing the city has a high cost. But for your typical users that will only do a small routes, the impact is not so large, but you still kind of get your time of traversing the town kind of being very similar or more than the one in the highway, and then Waze is not going to choose you anymore. And here, indeed, you need a lot of political power because you need the mayor of the city to make a change, right? Technology here is not the solution, technology is the support. And this is a lot of things that we write in that paper, the technology in itself, like without really human intervention, is very hard to actually make it work. Other kind of things that we put is that you can use actually technology to compute, to help people mess up with the loan system. The loan system is optimized such that particular people with particular attributes will get a loan and others would not, right? And what we've said is like, okay, you could have Robin Hoods, we call them Robin Hoods for the sake of some names, that would maybe kind of ask for loans even when they don't need them, and then repay them. And if this Robin Hood had particular attributes, you can actually start kind of shaping the model in ways that you want and get more people to get loans, but just changing the decision boundary. Again, you need people that have to do this, right? Technology on itself is not going to help. Funnily enough, I actually found out that there is people that already do this thing, not to get loans. This is a more perverse goal. You can actually pay people to get better credit on your credit card by having them kind of doing purchases for you and things like that, and then you would get more credit. Again, very important in the United States, not so important in Europe. But these are the kind of technologies, when we think about those, is how we can use technology to give people information to beat the optimization, right? Because otherwise, if you just try random things, it's not going to work. This also brings kind of other necessities, which is we need to know the algorithm, we need to know more about it, and that comes back from I think what Anna was saying in the beginning about we need transparency, right? And therefore it's so important the work of people that actually getting transparency on Facebook, how Facebook advertisement works, like the people of NYU that currently got sued in a big thing with Facebook, because if we don't know how all of these systems work internally, then not even technology is going to save us. I hope I have somehow answered some of your questions.
Sure, you did. I may have a reaction on that, but maybe I'll see if there's anybody in the chat, or if we have a virtual show of hands.
I don't know whether we have at this point, and you are absolutely all invited to ask your questions and make your remarks, but I'll just, Maël, if you don't mind, make a tiny follow-up, not to a question, but some of the issues that you have raised. So when I was listening to your exchange, I was really thinking about the paradox that is obvious and that is striking. So on one hand, there is this idea that people would like to or should be empowered by technology, and something should be done. But do you have any idea how to make this message clear, in the sense that there is this paradoxical attitude that people tend to have towards technology. Either they are completely confident and they really think that everything is going to be solved by technology. And sometimes the same people, not always the same people, but sometimes the same people are going to get extremely paranoid, as it was the case, for example, with the French and maybe German too application, you know, on it was called Tous contre COVID, everyone against COVID, you know, this kind of COVID tracking application, whatever. So out of the blue, people became super conscious, you know, the same people who use every application that trace them anyway. So how to frame the education that would even make it thinkable for people to feel that they own it, that they should own it, and that it requires an effort, right? And there's someone who wanted to ask another question, so you can either, yeah, whatever.
I mean, I don't have like the $1 million question about how to explain to people technology, right, and the impact. I don't have a very big answer to this thing. I wish I did have. I think a lot of it goes to education indeed, and the fact that we need to put more and more education kind of at lower levels. Like I see more and more, I don't know if it's the trend in France and in Germany, but like for instance, Switzerland is moving more and more to have kind of computational thinking, move to high schools and even to primary school. And I think it's important that we put a lot of pressure that also this thing that we're talking about today kind of also get into that, like kind of the negative impacts, right? We talk about technology in this very positive way. As to why sometimes people get super reactive to particular technologies and decide at that point that while some of the things are acceptable, that is not. I mean, I have a lot of thoughts about contact tracing apps, but I don't want that conversation to hijack this one, because I think we have a much broader spectrum. If we have time at the end, we can go back there. But I don't, yeah, I think that education is the same. And one main thing I have to say, and that comes from my experience with contact tracing apps, is that something that has a lot of power is media. And I found many times that where I was being interviewed on all of those things, kind of journalists were so on the surface and so kind of very worried about this, I don't know, having a much out of a very controversial opinion rather than explaining why and how. And then we don't get to the people, right? Because they read the newspaper, and if they just want to read polarized news, then it's very hard. And I wish sometimes we had better kind of journalism in that sense, that would explain more of the technology rather than just tell flashes about the good and the bad of it.
Yeah, the same for example, for medical technologies, and the same for the explanation of how the vaccine was created, etc. So I did have the same problem on my side. Okay, Dimitris Kotsinos, please.
Hi, you can hear me?
Yes.
Okay, thanks for the talk and the discussion. I basically have two comments to maybe add. The first one is on the, let's say, based on Maël's comments, where my concern is that we are starting blowing machine learning and AI maybe a little bit out of proportion. So what we can do technically is one thing. What we can do in terms of the social norms and what is, for example, fair for different, let's say, aspects or for different understanding that we have in the society is another thing. So marrying the two is something difficult, but in some cases, it's the situation is much, let's say, better than what it is with human agents when they are making the decision, where, for example, nobody accounts for the biases of the human agents when they approve a loan or when they hire someone, but somehow we account much better when it's in learning. So one point is that I think that we should acknowledge that. And to go back to the presentation and connect a similar comment there, for me, and being someone who is on the technical side of things, working in machine learning and AI and data science, I would say that what we call in general social science for social good as well, I would say that it is important to understand that humans would be in the loop. They would be now and they would be for some time in the future, at least, and hopefully for a long time. This cannot be avoided, but this does not mean that the role that, let's say, technology is playing, with all the problems that have been described, should not be there. And to pinpoint the example with the traffic that is used, which is a very nice one in my view, this depends again on how you set up your problem. So if your input is take every street and use it indifferently, then yes, but nobody actually forces us to take every street and use that the same way as every other street. So the question is basically, and this is an important question in my view, how much time and how well we work on setting up the problem correctly to pinpoint the actual reality, and how much we're just getting a bunch of data and we're saying, okay, work on that and tell me what you decide at the end. Thank you. I hope I didn't took too much time.
Thank you very much, Dimitris. Let me start by the second thought, because I'm going to be more controversial on the first one. So actually, you have a point, right? Which is that a lot of the problems that we have, for instance, in the traffic comes from the fact that we're treating the problem as a kind of this generic problem, and every street is the same, and it's the same to send people through the highway and through the middle of this village, or through the main road of the village, or kind of the more residential areas. And all of this has the same weight, and then is when we get into problems. And kind of my point, and maybe I didn't make this across, is that indeed the solution to this could be if we could just put tags on all of these roads and then have rules for this. But it so happens that the owner of the algorithm cannot do this. It is even unclear if we would put everybody in the village, right, to decide on these tags, they could be able to do that. And here is the point that makes that while that would be the desirable outcome and the desirable input, is kind of basically impossible to think that we're going to able to have such information and be able to input it in a framework that the optimization algorithm would be able to take it into account for the global good, if we even were able to kind of define the global good, because maybe the good for me is not the good for my neighbor and the other way around, right? And that is kind of the point here, that there are a lot of constraints that cannot be put there, and a lot of harms that may actually not be easy to interpret, to learn about them, because who's going to tell you that this old lady in this particular street, in this particular village, has a huge problem when cars come into her road? And even if we knew all of these things, how can we feed it into the algorithm? And then we have this disconnection indeed between the harms and what the algorithm does. About the fairness of the machine and the fairness of the people, I have to say we disagree here, right? We have people being accountable, and there are actually laws to keep people accountable for who they hire and who they don't hire. They may be hard to enforce, but those things exist, okay? And we did have, and indeed, some people have fairness problems. We have the study of the judges that make different decisions after lunch or before lunch. We have all of those things. We know that humans have biases. That's fine. But machines also have them. And the idea that machines do better at this bias, it's kind of a bit weird, because what we have discovered so far is that they don't. They actually inherit bias from the humans via the data, and other bias that we don't know about. And not only that, they apply it in a systematic way, in a much more systematic way than what humans do, which is also very problematic because it kind of increases the gap of unfairness. And the idea that we're going to put humans in the loop to help with this thing, also research shows that these humans in the loop, you know, they are not very good at contradicting the machine. Nobody wants to contradict the machine, indeed, because the machine is not accountable. And the machine is not going to be fired, but you can be fired. So we have a lot of examples where once you introduce algorithms on these places, it is very hard for people to stand up and kind of counter the algorithm. So I don't really agree that we're much better with machines than with humans. And maybe it's because we have not learned yet how to combine these two. And I would love, like, if we would get to that place. And one thing that I didn't say in this talk, but that comes, something that we said a lot with the synthetic data, is that the deployment is so fast, right? We don't have a learning phase, which we learn how this is going to work. No, you just directly put it there, and then it has the harm in reality. And then we try to backtrack. But at the point that we do all of that, the technology is already there. And this becomes very, very hard to fix.
Thank you so much, Cyrille.
Thank you. I have a comment if we have the time, but
Sure.
it's not necessary.
Of course.
Sure, please do.
Okay, so just to clarify first that my point was that not that the machines do better. Of course, as you said, bias exists in data, bias exists in the algorithms. The difference is that I have the same bias for all the cases where an algorithm are applied that is trained on the same data, so I can identify those. More difficult or more easy, it's another discussion. And for me, what is important is actually, and this was my point, that we need to differentiate that. We need to understand what is the bias that comes from the data. We need to understand what is the bias that comes from the algorithm itself, and so on. And also we need to differentiate if there is a problem with the way things work or with what input we are providing. It's a very old saying in computer science that says garbage in, garbage out. And this is much more strong in machine learning. I mean, it's garbage in, a lot of garbage out. So yeah, but for me, it is important to differentiate that, because it's something that shows that we start really handling where things go bad. And this also for me is the idea of human in the loop. The human is not there to contradict the machine. The human is there to provide additional input to say what is, let's say, good or bad, acceptable or not, and use this input to retrain the machine, so to evaluate the results, if you like. But okay, I get the points that there are cases for all the spectrum around, and yeah, I mean, you can have examples where things go bad in many different ways. So it's true. So thank you, and sorry again. Thanks.
Thank you.
Thanks so much. Cyrille.
Yeah, thank you for your talk. So it's a general question. I was wondering how much we are conceptually equipped just to think as about AR as technological objects, because for usual technological objects, we are going to expect that they were socially sure that they do not cause social harms, and usually it goes from with heavy procedures, and so for example for drugs or for cars or for planes, and we are going to say, look, you will not be able to sell this technology or these artifacts unless they are certified, and then we have social procedures to certify things. And so for example, in most extreme cases, for example with we have planes, and there are codes for planes, and then we are going to say, okay, look, or for scientific models, we may say in some cases, look, we even want very high level of certification. And for example, we want the codes to be formally verified. But here, and usually there is producing a technological object is difficult, but certifying is even more difficult. But in this case, it seems to me that it's, I mean, we are totally despair in the sense that it seems to be easier to create AI because you have an AI, just take a data set and you're going to train it. So you are going to have many technological objects that are produced. And from what I get from what you say, I mean, certifying AI is almost impossible to be sure that we can just guarantee that there will be no harms. So I was wondering, are we just correctly equipped, just from a social point of view, to discuss and to have the same expectations about these types of technical objects? So very practically, are there discussions about ISO norms related to AI, or is it just, okay, we just give up? Because in the same time, where there are AI everywhere, they are just spread, not in nature, but in society. So it's,
and in nature.
It's there, yeah.
I completely agree with you. And you have given examples that I give in many places, like why to put a vaccine out there or to put a drug, I need kind of 3 years of trials and attempt and make sure that we have a lot of procedures and ethical discussions about how much harm versus how much good it's going to make. But now to make an app on a phone that uses AI, I spent 1 month programming and I put it on the App Store and off you go. And if people pick it up and it's good, off we go. I am with you. And I think that is this kind of disconnection. And I think, I don't know what it is. And maybe you guys have a better view because I'm a computer scientist at the end of the day, right? I'm a technologist. I'm not gonna lie. That's also why my talk was very technical oriented, because I don't talk about things I don't know. But it's a very good question. Where did this disconnect happen? And at what point technology became this lawless kind of thing that we just can deploy without asking ourselves whether it's a good idea or not? Well, you have put very good examples, right? Cars and planes and medicines and a lot of other things where we have huge controls about what is good or not. But apparently here there is no, and I don't have an answer. I don't know what is the economic power that kind of pushes for this thing. But this kind of addresses, I think, or goes very connected with what Dimitri was saying, that yeah, we could separate what is from the data and from the algorithm, and we could know all of those, but knowing those things takes time. Takes a huge amount of time. And it takes even more time when you have 90% of the community just focused on the next great application that is going to get whatever thing, and only 10% actually focusing on those issues instead of the other way around, which is my understanding that maybe is what happens with medicine, right? You have everybody kind of concentrated on getting the drug out. Competing or not competing, but they're kind of on the same, well, here we are in this, because you can take shortcuts, right? It's very hard to get people to know this thing. I don't think it is impossible. I just think that it is impossible at this speed, right? We're doing these experimental things in which you just throw technology at people. Or if you think about how Google and Apple work, I don't know if you have gone to any of their talks on usability, like they do continuous A/B testing on us, like using Google, like you're being tested all the time. We're testing in this very kind of way that we don't realize, like buttons appear and disappear and these kind of things. It happens all the time, and apparently it's okay. I don't know. I don't have an answer. I am as shocked as you that these things happened, and I don't know how to really address it. Or I think as society we should be equipped to say no, but apparently we're not, because we try, but it's not working.
Well, okay, Mark Anderson wanted to add something, but I think that the problem is also due to the fact that people who master the field and people who decide for in this particular case of computer sciences are very, very different people, and they just do not master what is going on. So this is the huge gap here has not been met in any other, when medicine was popping up. Wow, this took time, yeah, when we had time to understand what was going on in medicine in general, in planes, whatever. It took years to even try to fly, and this happened really, and this happened on the side of games. It started, I mean, in the public, not in military, but when it popped up in the public sphere, it started with games and nice exchanges. So it was not taken seriously, and it started to grow as something not really serious, and the dynamic was completely different. So I think that this is the answer why, but this is not the answer to the question whether or not we have any grasp on it. Yeah, sorry, Mark, you wanted to add something.
Yeah, I was just thinking about, because thank you. First of all, thank you. Very lovely talk. Very interesting. But I was thinking about, you sometimes framed it as you talked in terms of power and trying to give the user power and things like this. I'm not sure if that's a helpful. I mean, there are soft sort of actions, I think, to answer the discussion that's going on that can be taken on the part of the technology developers. But I don't know if you regularly think about it. I mean, things go fast. Everybody says that, right? In technology, and it develops very fast, and it's faster than human scales of speed that we're evolutionarily equipped with at the moment. And so it's tremendously fast. It's too fast for us to think about it, and socially for us to plan about it, and so on. But do you think in that case that I mean, not you personally, but technology developers, computer scientists, have a responsibility and an opportunity maybe to approach it there and say, okay, we can slow down. We can slow down, we can think about it. If we, before passing it on to somebody else to think about, we are the ones developing it. If we can't slow down, who can? But we can't slow down. I imagine we can. I mean, obviously, the technology developers have those outside market pressures, and everybody has a job and is paid and whatever, and they have to do. But I think if you can't do it there, then you'll never do it. And so you have to have that internal discussion among technology developers. And sometimes it'll be slow down, and sometimes it'll be, more extreme. Maybe we shouldn't develop this, or maybe, at least I shouldn't develop this if I'm one of the people working on it. And at least take a stand and then get the discussion going among, the community of developers. I don't know if you think is a fair point to say that that is maybe a responsibility in a way too.
I completely agree that technologies have a lot to say, and technologies indeed can say yes or no. As you said, there is a lot of things that have to do with the market and the pressures and the fact that we live in a capitalistic economic system where incentives may not always be, but indeed as a computer scientist, you can say, no. I have to say, I think it's hard many times, right? Because it is hard for me to say, I don't work for Google, which I try to do to the extent that is possible, right? But then that also means, for instance, when I decide myself, I'm not gonna work for Google, and I'm not gonna do any of these things, I'm not getting money from them, but that also means that I'm kind of telling my students that they cannot get a Google fellowship. When they don't get a Google fellowship, they have less opportunities than others to get the thing on the market, because it turns out that, hiring committees are like, oh, this guy has a Google fellowship and this guy didn't. And some of these guys didn't. Also, I have to say my students, they also don't like Google very much, right? Because we work on particular topics and with a particular angle that makes that harder, but it is kind of hard. But indeed, I try to do this more and more on my classes. I teach computer security and I teach privacy technologies at the university, and to put this idea in the brain of students that they are responsible. They need to think, and you cannot do this thing of you just put the technology out there, because as we were saying before, it's like being a pharmaceutics and working on a pharmaceutical company, putting a drug out there that you didn't test enough. Like they would never do that, right? That doesn't enter in the people's mind. Why do you do this with technology? This new idea that you have, that you're gonna put this thing there and you don't really know, which communities is gonna benefit, which communities is gonna be horrible for. Are you actually having one particular subgroup that is gonna be really, I think one very good example lately was the Apple child and sex and abuse system, yeah, where, I mean, regardless of the privacy and security issues that it comes, one of the people that really came out very hard was the LGBT community. I don't know if you have read about this. Okay. So Apple had two main systems that they were proposing. The one where they were going to scan all of the images on your phone and then say when something was very bad. And this is bad for many reasons, but I'm going to put it aside. They also have another one that is for kids. They could actually check their photos in the images that they were sending in messages. And if there could be any nude photo, they could flag this to the parents. And then the LGBT community raised a big voice because they said that this is a very bad idea, especially for trans kids coming out. Because indeed, you may have nude pictures because you're actually being kind of hunted by a sexual predator, and this is a bad idea. But for these trans people that maybe they don't have support of their families, actually they do exchange these kind of photos to explore their bodies, to explore other people's bodies, and they do a lot of those things. And they were raising an alarm about how much damage you could make to these kids. And again, you're putting a technology with the goodness of their heart. I don't know when Apple did this thing. I'm just going to believe they have goodness somewhere. But they really kind of didn't think about that particular corner. We do a lot of these things with technology, but we're responsible, right? Because the moment you put out there, you're responsible for what happens to those kids. And it is very important that we think about that. Now, it is very hard to do some of those things. Sometimes, again, where do you take the information? When we did the contact tracing apps, in the first month, I mean, besides a lot of technological work, I had like 10 minutes with civil society. We had 3 different workshops with civil society across Europe and North America. And I wish we had contacts with others in other places, but we just didn't, right? To just understand, like, tell me things I don't know. Like, where can I do harm that I have never thought about? Because it turns out that I'm a very white, privileged woman that has a very high salary in a Swiss university, right? And I'm in a particular place that no other people are. And this is very helpful, but this also kind of delays your deployment, and also makes it hard many times to sell the product, because products are sold to majorities, not to minorities, right? Who cares about the minority? We get the majority to pay for the product. And these kind of things, again, we went back in a loop to the market that kind of creates a difference. And all of this is to say, I agree with you. And I think education is a very important thing to put into technology's minds, that they are actually the doctors of the future, and that we're actually giving drugs around. And for instance, all of these algorithms that go for engagement, they could be considered straightforward drugs. Yeah, I don't think we'll get people hooked to YouTube or to these things. And yeah, I don't know. I don't know how we're going to do that. If you have ideas, let's go.
Thank you.
Actually, this is exactly the concerning the education. I know, Mark, whether you wanted to add something, please do.
No, that's okay. I just think that, I guess, you know, we think it, at least a lot of people do, we think it can be done in, for example, in political ways. We go out, we demonstrate, we do those sorts of things. In some sense, I think maybe we're going to have to come to having that within the communities which develop these things in some form, you know. I don't know how else we're going to, because if we don't get it there, I don't see how the average person can, because they don't understand. It goes not only too fast for them, they're bombarded by information, they're bombarded by new apps and new things, and anyway, that's my 2 cents.
So the
things that happen, like in this kind of what we're going to do, and the saying no, right? For instance, I did a lot of work in these contact tracing apps. I did zero work on digital certificates. I think they're the worst idea. Bad, like technologically, we cannot do many things. In fact, we predicted a lot of things could go wrong. All of them went wrong because it's not good. Now, when I do these things, and many times I kind of say no, and like we could build a system that would be better than the one that is there, better in some angle, like maybe more privacy preserving or maybe more fair. Like we do have ideas to do this thing, and I still say no, because if I don't believe on the goal of the system, and I think that there are harms that I cannot address, then we should not build the technology, right? We should not do the thing. And then comes the pressure of, but if you don't do it, it will come with someone that does it worse, which it happened. And then it is a very hard decision to make. And I don't know, in the contact tracing apps, we took one, which was to do something that maybe should have never been deployed, but at least the ones that were deployed made no harm. And were maybe, I don't know, I don't think they were a waste. Like they did do save lives. I don't know how many, but they did this notification, they did their job. But then that is the question, right? At what point kind of you situate yourself on the damage contention, or at what point you say no? Like, and that I found a very hard decision. And when I talk with other colleagues that are kind of on the same kind of wavelength as me, and yeah, we have a lot of power to build technologies and to do things, and when to say no and when to say yes, or when to say, yeah, okay, it is better to have the system with kind of moderated damage than nothing, because it's going to happen, right? Like somebody's going to come that is going to say, I'm going to do it. It's going to be great. And they're going to do something that you don't want. And I don't know what to do with that either. I have a lot of sleep problems about that.
Okay, wonderful. Thank you so much for sharing that. To be honest, exactly the question of how to talk about this, how to teach these questions is going to be the question that we are going to try to solve to some extent in summer. So I'm sure that Maël is going to share this with you. I'm going to stop the recording